In this video, I'm going to do 3 examples of drawing molecules with VSEPR geometries so we can get some actual application of the geometries you saw in the last video. So the first example is PCl3. So step 1, we need a good Lewis structure. So I need some valence electrons. It's 5 plus 3 times 7 equals 26. Phosphorus is my central atom. I'll attach my chlorines with bonding pairs. Put lone pairs around my outer atoms. And I have used 8, 16, 24. I have 2 electrons left to put on phosphorus and fulfill its octet. So I do my formal charges. Everything has a 0 formal charge. This is my best Lewis. So drawing the VSEPR geometry, I only have to worry about the steric number of the central atom for right now. For the shapes that we're going to draw, you are going to have to worry about it for all of them when we get to some later videos. So the steric number on phosphorus, I have, let me highlight these so we can see them. I have 1, nope, helps if I actually hit the highlighter. I know you all can't see this, but 1, 2, 3, 4 things attached to it. So those 4 things, 3 of them are atoms and 1 of them is a lone pair. Now I'll do a little side note because you won't see it in the example videos. If one of those things was a double bond, it still just counts as one thing. It's basically one slot in the spaces around that central atom that is filled with some kind of attachment to something. All right, steric number 4, but the coordination number, right, only 3 of those things are atoms. The coordination number is 3. So if I go back and look at what was drawn in the other video, I get some good clues. This is going to be a trigonal pyramidal shape, but you can start by taking phosphorus, putting the shape of things around it that would fit for tetrahedral because that's the electron geometry. Now, one of these spaces is filled by a lone pair. It ends up just being convention because it makes the shape easier to see that we put it in this spot that I'm going to X out in red because we're going to redraw this and not have a bond to a lone pair. You can technically put it in any position you want. So if you see it better in another position, as long as your drawing is clear, that is totally fine. All right, so I'm putting my lone pair in this position. So my other 3 spots are occupied by chlorines. And what I would like you to do is include all lone pairs and all formal charges on your VSEPR pictures. So this needs 3 lone pairs on every single one of the chlorines. All my formal charges were 0, so we don't have to worry about it. And this is my final picture of my VSEPR geometry. Okay, example 2. We're going to do BRF3. So this is 7 plus 3 times 7, 28 electrons. If I put together my Lewis structure, so bromine is listed first and is less electronegative. So it's my central atom. I'm going to attach my fluorines here with bonding pairs. Put octets on my outer atoms. 8, 16, 24. Oh, I still have 4 electrons that I need to find spaces for. But bromine is third row or below in the periodic table. So I do have the ability to expand my octet on bromine. So I can actually put both of these lone pairs on bromine, right? Fluorine, I cannot do that with because fluorine's in the second row, can't expand its octet. I really can't do anything else with it. So I have to keep my fluorines with 3 lone pairs in a single bond. And if I calculate the formal charges, I'll find that that setup gives me 0 formal charge on fluorine. And here, very nicely, let me double check this for bromine, 7 minus 4 lone electrons minus 1/2 of 6. What do we got? Oh, did I count it right? 2, 4, 2, 4, 6. Starts out with 7. 1, 2, 3, 4, 5, 6, 7. 7 minus 4 minus 3 is 0. This is what I get for doing math on the fly. So bromine also has a 0 formal charge. This is a great Lewis structure. I mean, you probably didn't want to put a halogen in the middle, but it worked out fine for us. So bromine has 5 things attached to it, right? I've got 1, 2, 3, 4 for that lone pair, and then 5 for that lone pair. Steric number equals 5. That means I have to worry about Bent's rule when I put this together. Here's my trigonal bipyramidal basis for how I'm putting these things around bromine. My lone pairs need to go equatorial. So these 2 positions that I've X'd out, I'm going to put lone pairs in them. So here's where I'm at. Can also double check fluorine was super small, right? And fluorine's in an axial position. Now, I mean, I had 3 of them, so the third one had to go equatorial. We didn't really have a choice, but fluorine versus a lone pair, fluorine goes axial. Fill in my fluorine lone pairs so that my structure is totally complete. And looks like I have everything, and I have a T-shaped molecule. Last example for this video, I'm going to do IF4 minus. So my valence electrons, 7 plus 4 times 7 plus 1, you can't forget counting electrons, and this has a negative charge. I have 36 electrons to work with. I'm going to put my fluorines around iodine because it is less electronegative. It's listed first. It's definitely the central atom. Put lone pairs on my outer atoms. 8, 16, 24, 32, 33, 34, 35, 36. So we don't like having things done this way, but you can expand the octet of iodine. It might feel weird, but it's perfectly acceptable because iodine is way below that third row. You have the ability to expand its octet. Now, I do need to calculate formal charge. I didn't do this explicitly for fluorine, but let's do it for these. We should find that we get 0, like I told you would in the last example. So 7 minus 6 lone electrons minus 1/2 of 1 bond, which is 2 electrons, gives me 0. Right? 7 minus 6 minus 1. And iodine, I should, off the start, predict that this is going to have a negative formal charge. My molecule has a negative charge. That formal charge has to be somewhere, and it's definitely not on fluorine, but let's see. 7 minus 4 lone electrons minus 1/2 of, it has 4 bonds, which is 8 electrons. So 7 minus 4 minus 4 is a -1. Wow, okay. So I have how many things around iodine? I have 1, 2, 3, 4 bonds, plus a lone pair, plus a lone pair. So that's 6 things. Steric number 6. Only 4 of those are atoms, so coordination number 4. So I can kind of predict, I could look back that I'm going to end up with a square planar shape. Let's get my iodine in the middle here. We can just start with our octahedral shape, right? It's a steric number of 6. I have to pick one position to start putting lone pairs in. The way that we've kind of traditionally done it is to pick one of these positions here. Let me make sure that this is all drawn in properly. All right. So I have my 6 positions. We tend to pick this one, although there are other ways that we tend to draw a square planar that kind of ignore the lone pairs that are around the structure. I'm going to stick with the ones that are nicely showing the geometry. If I put my first lone pair in that position, the second one has to go as far away from it as possible. So what I end up with is iodine, lone pair, and then my fluorines are all attached in this square shape that's all in the same plane, which is why it's square planar. And I need lone pairs on my fluorines, and I need that negative formal charge indicated on my iodine. So every structure that you do in a VSEPR shape should include all lone pairs and all formal charges.